Okay, moving on to related rates. Damn, we're like speeding through this. All right, so kind of the steps to go through. First off, always write a let statement. You don't want to lose 0.5 marks because you don't define your variables and you also don't define your units of your variables. So just make it simpler, start with a let statement, and then after that, you want to write down everything you know and everything you need. Okay, those are the first two easy parts. The hard part is what's in red, is essentially you want to write the question as a singular function. So this, you might have to define a variable in terms of another variable. Yeah?
What if you can't do that because your function is really hard to...
Oh, I know exactly. We're going to get to that. We're going to get to that. Yeah. That's our next slideshow. We're using the example from your guys' midterm. Yeah. Okay. Or like I'm kind of explaining that. Anyways, and then after you have the function as a singular equation, you're going to implicit differentiate that function, rearrange it and solve for what you need, what you haven't been given, and then in your therefore statement, just make sure you include the units. And you can also use your units to double check because you know that like the derivative would be like units over units. So just make sure it's like milliliters per time or milliliters per second. So that's just a way to check it. Okay. But how do you determine the equation to differentiate? That's such a great question. Thank you, Daniel. So there's kind of three different main questions that they'll ask. The first is like geometric, so they'll give you kind of a cylinder, a cone, or a shape. So then you have a function of volume or a function of area. And then you can use similar triangles or kind of ratios of one side length to another side length to determine one variable in terms of the other variable. So for the example that we're going to do, you're determining r in terms of h. The second one is for distance. So this is kind of ships or police officers. You want to create basically as many right angle triangles as you can, and then you'll also have one side length if you're kind of cutting a side length in half. One of those side lengths will be x, and the other side length will be a constant minus x. So that's if you've seen the problem where you're on an island going to shore, where should you go on shore? One of those side lengths from where your landing zone would be x, the other side would be with the length of the shore minus x. And then the hard one is when you're given a function. So for the Math A second midterm, they were given some like chain, but the functions weren't related together. So basically, the best way that I've thought about explaining this is the functions aren't related in any way aside from that they have the same variable. But you know that you want dE, dL. But you don't know how to determine that. But you know that you have dE dA and dL dA. So how do you kind of get rid of dA? You divide it out. So you're able to divide out derivatives to cancel out kind of those units per se. That's what's actually getting canceled out. But to get to a derivative that you want. So in this case, you're dividing out by dA, so then it cancels out dA, and then you're left with what you want. So you're able to like multiply or divide out to get to the units of what you want. Does that make sense? Are there any questions about that? Because I know like during the midterm, I can imagine how stressful that would be when there's no relationship between the two functions, but sometimes even though it's like nicer to write f prime of x, sometimes it's better to write it like this, so then you can actually see where the units are and how to divide out the units. So if you're ever stuck, try writing it a different notation, and then you can see, how can I divide out these units, or how can I get it to the units that I want? I think that would be pretty helpful.